Welcome. We're going to be going over the quiz angles. Well, I guess the quiz you took over angles. So let's go ahead and get started. It says right here, draw each angle, include an arrow to indicate the initial and terminal sides. Also identify what quadrant the angle lies in. So let's go ahead and get started with this one. Now with this one in particular, being 210 degrees means that I'm going to go ahead and draw my, my four quadrants because this angle is actually going to do a revolution over quadrant 1, quadrant 2. And let me go ahead and write it down. Q1, Q2, Q3, and Q4. So it's actually going to do a revolution right around, we have quadrant 1, which is 90 degrees, quadrant 2, which is 180. When you hit here, this is 180. So then we have to ask ourselves, from 180, how much does it travel? It travels 30 more degrees, so roughly right about there. And this is known as the terminal side, and this is known as the initial side. So if I was going to label this, this will be initial side, and this one over here, terminal side for an angle. And the other thing that's important to keep in mind that this was 210 degrees, and it lies in quadrant 3. So we went ahead and identified all the items that they wanted us to do. Identify the initial side, terminal side, identify the angle and which quadrant lies in. Okay, fantastic. Let's go ahead and do number 2. Now number 2, it says convert the angle to decimal degree notation. Round your answer to 2 decimal places. Now with this, I'm going to go ahead and bring up my calculator because it's going to require that. And the other thing we're going to have to do for this one is that we have to go ahead and remind ourselves of a couple of things. To convert this to angle to decimal degree notation, we're going to have to multiply the 123 by 1, and then we're going to have to go ahead and add the minute part, 17, multiply that by 60, 1 over 60. And we also have to go ahead and multiply the seconds by 1 over 3,600, which is how many seconds are in an hour. So let's go ahead and do all that. So this is really, now this could also be written like this. So for some people, they might find it easier just thinking like this, multiplying, dividing that by 60, the minute notation by 60, and multiplying this, or dividing the second part by 3,600. So let's go ahead and actually find out what that renders us. If I go ahead and do this, I'm going to bring this up real quick. Okay, good. That means I have 17 divided by 60. Comes out being 2.8. So let me write that down. Well, actually, I'll do both of them, so then I could just write them down at the same time. Divided by 3,600. All right, so 0.00, well, that's going to be then 0.001, because it wants us to round to 2 decimal places. So that means that for this one, this is 0.01, and then this one over here, let's go ahead and bring up our figure back again. That's going to be 2.8. 0.28, and I had originally 123. So I add this all together, it's going to render a result of 123 plus, well actually, not plus. Well actually you could think about that, 0.29, since I wrote the plus already, but typically you just write the answer, 123.29 degrees. So there we go. And so that converts it. Now let's go ahead and look at the next one. Convert the angle to decimal minutes second notation. Remember with this one we're going to have to separate them apart. So when we do the separation, one of the things I'm going to need you to do is separate the number from the actual degrees. So the first thing we'll do is 52 and separate that from the decimal. So we had plus 0.386, and then from there we multiply that part by 60, because remember we're converting it to minute second degree notation. So now with this one it says it wants us to round to the nearest second. So we'll round to the nearest second once we get there. So let's go ahead and now do that. 0.386 multiplied by 60 renders a result of 23.16. So that means that my answer, I'm going to have 52. Okay, and we're going to go ahead and put that down as degrees. And then we had this whole number. The 23 is now going to be my minutes. So that means that in this case, 23, I'll have 23 minutes. And then I'll have to add just the last part, which is the second notation, so 0.16. And I'm going to have to multiply that by 60 as well. Because now I'm trying to figure out what it is in minutes. I mean in seconds. So let's go ahead and do all that. 0.16 times 60 means I have 9.6, which means that I want us to round to the nearest second, so that means I'm going to have 10 seconds in this case. So in this case, this is going to end up being 52 degrees, 23 minutes, 10 seconds. And there we go. And we go ahead and we have question 3 answered. Okay, now let's go ahead and move on to the next one. Next one, they want us to go ahead and convert from degrees to radians. Express your answer as a multiple of pi. Now with this one, to convert from degrees to radians, we have to apply a factor. You have to know this conversion factor. Pi times 180. So what do we do from here? Well, we're going to have to reduce 150 over 180 pi. You can do it by hand or you do your calculator. I think a lot of people opt for the calculator because it's a bit easier. What are you going to do? You're going to do math frac. So you do 150 divided by 180. Hit math, frac, enter, 5 over 6, which means that the answer for this is really 5 over 6 pi. And that is what it is in radians. Okay, now once it's converted from radians to degrees. Now when you do the other way around, you have to use the reverse of the other ones, 180 divided by pi. Now, we do that, the pi's cancel out. And so, and you know what, let me rewrite this, because I know some people pi didn't see that so well. That's really pi divided by 6. And remember, a conversion factor is 180 over pi. So when you see this, this shows the pi's cancel out a little better. And then 180 divides into 6, or 180 divided by 6 is 30 degrees. Again, you could do that in your calculator. But that's the answer. Okay, let's go ahead and now do our, oh, you know what, they gave you the equations right here. So that's lovely. They want us to go ahead and actually use this notation to go ahead and actually find the arc length. So let's find the missing quantity where S denotes the length of the arc, R denotes the radians of the circle, and your degree angle denotes the measure of the center angle. Round your answer to 3 decimal places. Okay, so first thing we're going to have to do, we have to make sure we work in radians. So we know what our R is. Actually, R is unknown. Angle is 120 and 9 is 9 millimeters. So we have our equation. So all we have to do is now substitution. This is 9 millimeters. So let's go ahead and write that down. Let me substitute now. 9 millimeters is equal to R times 120 degrees. So we're going to go ahead and put 120. Now remember, this needs to be converted to radians. So we need to convert this to radians. So how we're going to do that? We're going to take 120 and multiply that by pi over 180. Okay, so again, you can use your calculator and math frac that to find out what the amount is of there. 120 divided by 180, math frac, 2/3. And you also can do it by hand. Actually, I would say that I would do it by hand, but I know that some of y'all want to go ahead and just double check with the calculator to make sure it's right, so that's where you have the calculator. Okay, now what is this as an amount? because I have to get a specific amount for this. I keep things as in pi, but I think it'd be better if we actually did amounts. So let's go ahead and do that. 2 divided by 3. Second pi comes out roughly being, now since they're reducing to, I'll go ahead and pause this for a second. Okay, since we're dealing with these numbers and they're asking us to convert to decimal places, I will do that as well, just to keep the notation of similar. So this is approximately then, oh, what's my number? Around 2.10. That's what it comes out. Well, 2.09. Let me go ahead and put that down. 2.09 for approximately 2.09. And you need to use the little approximate symbols. So that's what I'm going to use here. So I'll have 9 millimeters is equal to R 2.09. So when I go ahead and solve for this, which means that now I divide it by 2.09, 2.09, I end up finding that R is really just 9 millimeters. So 9 divided by 2.09, which comes out being 4.3, I'll round again, 4.31 millimeters. So that means that I'll have 4, remember use the little approximate symbols because we've so far rounded. So we are approximating radian will be, the answer would be 4.31. Okay, let's go ahead and move on to question 7 and the very last one. Now again, this one, they gave us the equation. All we have to do is just do the process of substitution and solving. So I know what A is, so let's go ahead and start doing our substitution. 5 meters squared is equal to 1/2, and R, I do know what it is. It's 3 squared, and I don't know what my angle measurement is, more of anything. Okay, so let's go ahead and continue with solving this one. Now this one actually is pretty simple to solve because all we had to do with this one really didn't require much of a lot of manipulation. It's because you could go ahead and actually, this part right here, you could actually make it into a number, and then after it just divide. Sometimes when you're doing the other ones, like we didn't know, I think that this one was difficult when you don't know R, but in this case, since you know R, it's a simple problem to do. Because from right here, all we got to do is, we all know that 3 squared is 9. Hold on, let me bring this up. So we'll have 9 times 1/2, which would be 4.5. You did that, you should have found out that was 4.5. So from here, let's go ahead and do 5 meters squared. And we'll have 4.5 this angle. Now, when I divide by 4.5 and I divide by 4.5, I'll have roughly an angle that gives me, in this case, 5 divided by 4.5. Now, one thing I want to make sure is, let's see, okay, one thing you do want to make sure, we're left with meters. This was meters right here. So we'll have meters there. And the reason why that's important is that once you multiply all that out, you'll still have meters there. Actually, you know what? Let me do that in a different color, because then it'll illustrate the point that I'm trying to bring out. Meters, meters, meters. When you have meters here, when I do the division to find out exactly what the angle is. Remember, lastly, I'm doing this division to find out what is this angle measurement. And if they ask you, sometimes you do need to, like when you look at your answer choices, not so much in this one, but when you look at your answer choices, they're asking you a problem like this and you find out that everything's radians. Sometimes you have to convert back. But let's, I want to demonstrate that one of the meters cancels out with one of the meters on top. Because remember, the radian angle is going to be given to you as far as meters. So let's go ahead and now do, okay, let me go ahead and bring that up. 5 divided by 4.5, 1.11 repeating. So we have 1.11 repeating. Now what is that? Well, then you write that down. 1 point, and I'll round. 1, 1 to 2 decimal places because that's what we've been doing. So you can say approximately. Let me go ahead and erase that. You go ahead and write down the approximately. Our central angle will be 1.11 in this case. All right, fantastic. Now, I know that some people were confused with this problem because we had to solve for radians, but that was not the case for this one. Or not radians, for radius. In the example I gave, this one was the angle, so that's what made this one so simple. Apart from that, go ahead and study this video until you think you master. Remember, try each problem over. That means that cover up what you've done so far and retry it on a separate piece of paper. Make sure you're able to remember, apply it, and well, actually remember, understand, and apply. Those are the 3 things you got to be able to do before you come back and take a retake quiz on this. All right, thank you.